Okay, good afternoon, everyone. I hope you can see me, my screen, and you can hear my voice. All good? Hello. Can you hear my?
Yes, sir.
Okay. Right. So here we are to discuss two very important topics under one unit title. So we are covering the software engineering and also the software engineering project or the software project, right? So two different things. We'll be covering the engineering aspect of building software. Now, software building, we say, is an engineering aspect, right? Because it requires a lot of thinking, planning, a lot of work. So we'll be going through all the steps required to design a complex software. Along the line, we'll be covering a few things. I'll show you in detail. And at the end of this unit, we will be building a project. So that's the plan, right? So let's first go through the details of the unit. A little bit about myself. I come from a software development industry. I've been working for a software development company for a long time. Build few things and help starting a few companies, and then moved on to the academic world a few years ago. So my focus was multimedia, actually, multimedia education, and also I've been covering many different aspects of software building, delivery, mobile apps, web-based application development, and things like that. So if you look at the aim of this unit, we are looking at one very big concept, actually. One of the, I would say, very important aspect of software building, because when it comes to finding a solution to a software problem, the primary thing is to figure out what the problem is, what problem the customer is having, right? So then we come back to office and maybe we'll try to model the problem the customer is having using our software solutions, or rather the computer language, maybe computer algorithms, maybe whatever, maybe. Now there is actually two different worlds here. The customer is looking at the problem the customer is facing, right? Like, for example, if you are to build an accounting package, the customer is worried about the bank slips, receipts, invoices, let's say production planning, paying to their, let's say, the suppliers, collecting money from the customers, things like that. Whereas the software developers, we have a problem of trying to map that problem into how we are going to build our software. So we have issues like, okay, which language to use, or which data structure to use. Are we to use array? Are we to use variable? Are we to use a loop? How do we store the information in the database? Those are our problems. So we are actually living in two different worlds. Now, object-oriented programming will help us to bring these two worlds closer. So we will use our software system to model what the customer has. For example, in our software, we can design an invoice. And in that invoice, we can also have, let's say, a payment. Or if you take the other way around, if you take a payment, we can have an invoice inside that. So, various aspects of software can be used to model the problem we are going to solve. So object-oriented programming is actually a way of thinking. Right? It's not just a programming language thing, but it's a way of thinking. It's a very generic way of thinking. So you can use any programming language and apply object-oriented principles there. It can be Python, C#, PHP, Java, JavaScript, any language for that matter. You can use any language and apply the object-oriented principles there. Like I said, this is an engineering task, like building a house or building a bridge, maybe building a ship. It's a very complex task. So we have to know the fundamentals, the theories. Only then we can make a great impact on our product. So the aim is to understand these principles and then use these principles to develop a project which we can use. So in order to do this, you have one prerequisite, that is the ECS2301 Programming Fundamentals with Python. That unit introduces you to the fundamentals of programming, right? What is a variable, what is a loop, and then how to get started, how to make simple applications, stuff like that. So we take that into a little bit advanced mode using object-oriented principles and various other aspects to build a production level application. So that is the official prerequisite, ECS2301. But it also, rather, this unit also requires a lot of thinking in your algorithms and programming principles, things like that. So I assume you have built a small code, like say how to, let's say, find prime numbers, maybe factorials, Fibonacci sequences, finding the largest number, smallest number, so stuff like that. I assume you're already done, right? Have you done any of those code while you're learning Python? What are some of the samples that you've done when you learn Python? Can somebody tell me the kind of programs you learn under Python? Can somebody talk, please? Gisara, are you here? Dulara? Okay, so we discussed the prerequisites. Talking about the assessments, it's broken down into 4 areas. We have continuous assessment. We have continuous assessments with, like, every week there will be some work. I suppose you know how it works. So I will upload something for tomorrow. So tomorrow is our first activity day. There will be a teaching assistant available for you. Even if you don't have a teaching assistant, there will be things loaded to our LMS, so you can have a look at that. This week is fairly simple. So I want you to install a piece of software called NetBeans. Install that. Along with that, there are a couple of other things you need to install. There is something called Java, JDK, JRE, stuff like that. So there will be a guideline showing you how to do it step by step. Install it and write a simple program and be ready for our next week class. Along the way, I will also introduce you to a suitable short Java program online. If you do that, you will get 5% marks. I thought, because to give you a variety, to introduce you to one of the online courses as well. There are so many courses available out there. YouTube is full of courses. There are Java tutorials available in English, Sinhala, Tamil. So you can go there to learn some of these concepts. Like I said, this unit, this module has lots of new concepts, and it requires a lot of attention from you. You need to start thinking about it. Okay, what does it mean by encapsulation, for example? Where are we using it? Or what is a decorative pattern? Right. So this is not a exam to see whether you remember anything. This is a place where you are going to apply this. Say, for example, if you're building a coffee shop, you need to apply the decorator pattern into, let's say, calculating the cost of a coffee. Right. So that's how you apply that. That's how you learn, as an example. Rather than remembering, okay, decorative pattern is this and that. Nobody cares if you don't know where to apply that. And then, of course, there will be a mid-semester exam and a final exam. And they're also very practical, where rather than memory, we are looking at whether you can apply what you are learning into different cases. Okay, so that's on the assessments. Now, if you look at learning outcomes, every module has something called the learning outcome. So this one has 3. So number 1 is to understand the object-oriented programming principle. So we call it a paradigm because a paradigm is something different, completely different way to what we are doing now, for example, right? Say we were using typewriters long time ago, maybe 30, 40 years ago, we were using typewriters to type. So those days, young people just out of school, they go and study shorthand and typewriting. Shorthand is to take down notes very fast. It's a different code mechanism to take notes, and typewriting to type what you've written. But when the computer came, when the word processing came, the typewriting and shorthand is completely gone, right? Now, those days, managers used to have a secretary. Not anymore. So manager is the secretary. Now manager has to do reply to the email, typing documents and everything else. So that's called a paradigm shift. So same thing with, let's say, a horse cart versus the car, right? So when the car was introduced, there is no requirement for horses or horse carts. So that again is a paradigm shift. So object orientation is also a paradigm shift in program. It's completely different way of building software. And then we are looking at building simple program using a language called Java. In fact, Java is selected because it's a solid application programming language. And also particularly, it's a very clean language to learn some of these principles. There are so many others, like I said, you can learn the same object orientation with Python or C# or PHP, any other language. But then Java is selected for lots of different reasons. So you can, because there are electronic students here, there are I students here, so many different varieties are here. So Java can be used if you want to program your IoT device, right? There is a Java micro edition for that. And if you want to program desktop computers, there is a Java standard edition. And if you want to build an enterprise level, insurance system or a banking application or whatever, massive one, that is Java Enterprise Edition available. So, and also it is full of lots of different libraries. And it's very matured. I think it's almost now 25 years or so. More than 25 years, I believe. 1995 is when it was launched. So it's very matured. There are a lot of help available on the internet. So that's one reason why we selected Java. And also Java can be used to build a desktop application with icons, menus and things like that. We call it the GUI based application. So you can use Java to build graphical user interface applications as well as other traditional, maybe text-based or web-based applications. The third point is we are also going to build a project, right? So there will be a couple of specifications. We've yet to see whether it is going to be an individual or a group project. I think we are inclining towards the group project. So we'll discuss some of the topics that are suitable as a project for you to build. So these are the learning outcomes. So if you look at the scope of this unit, now the details of the learnings. So there is some jargon here, as you can see. So we are looking at basic control structures, functions, pointers, arrays, encapsulation, information hiding, polymorphism. So these are big words, by the way, right? So that's why I said you need to go through each word here. Of course, I'll do that in the class, but you need to start thinking about it. So what do you mean by information hiding? Where are we using it? And what is the sample code, right? And if you are building a production level application, where will you be using information hiding as an example? So every topic here has a practical aspect of that. So you need to understand where you will be using these topics. And then we're also writing down some GUI based application, because that brings in another concept called event driven programming. Event driven programming, where when you click a button or when you drag something, when you start typing, it generates something called an event. Now, from the electronic point of view, this is called interrupt driven programming, right? If you've done electronics, interrupt driven programming is where you just wait for the interrupt to happen, and when the interrupt happens, you start a certain program to run. So very similar to event driven programming there. And we are also looking at software engineering fundamentals, things like design patterns, things like UML, stuff like this, software requirement specifications. So those are the concepts you need to build a very robust application. And with all that knowledge, we'll be building a project at the end. So as you can see, there are a lot of words, a lot of big words here. I'm guessing you may have not heard some of these words before, right? Any of these words have you heard before in your previous classes, any units?
No, sir.
Nothing? All right, okay, so it's all new then. So this is again broken down into a delivery mechanism, something like this. So this is like a very high level delivery mechanism. So we have first try to understand the development life cycle. Maybe next week we will do project groups, and then we look at the process model, object concepts, UML diagrams. We also look at testing process, design patterns, and also agile process that we can use to build complex applications in a very predictable way. And then we also look at GUI and event-based programming, and also how to do debugging using a concept called exception handling. And then there are something called the non-functional requirements, like say how much memory it is using, how much of various other resources are required. So that we look at as well. And along the way, we will also have a project progress reviews happening, right? So that's how the subject delivery is happening. Okay, which brings us to the first topic here. Actually, before I do this, let me jump a little bit into our portal or website. Let me get to the website. Right, I hope you can see the website here. I mean the Moodle here. So this is the module. I've loaded few things to week 1. Okay, so today's presentation is loaded here, and I also loaded few interesting video clips. So this is a series of videos regarding software engineering basics, and this is also an interesting one. I thought if any of you want to join or build serious software, there are other additional skills you need to master, like source code management, There is also something called Docker and things like that. So it talks about those topics and also have pointers to learn them if you want to. We'll be using IDE or an editor called NetBeans throughout this program. So this is a video about how to install it onto your laptop, right? So that is one. And then this one is about how to get some assistance from the IDE. I'll show you how to do that as we move forward. So once the lesson is done today, I will upload my recording. So that's how I've organized our Moodle here. And time to time, check the announcement. You will also see, an indicator there if there is any announcement. So click this and see whether there anything important posted. So right now, I guess I just started one. So no messages yet, but I will as and when it is needed. Okay, so coming back to the presentation, building software, what does that mean? Well, building software is similar to building anything, whether it is a house or a bridge or a circuit or a telephone, whatever it may be, you're building, right? So it requires some discipline, some certain knowledge, right? Some experience, things like that. So if you look at, say, for example, any software project for that matter, one of the first problem is understanding the problem. Or we say in technical terms, defining the problem, right? Now, most of the time, this production level software, we do that with a team of people, right? So how do you let the team understand what is going on or understand the problem of the customer? Because customer comes to us with a problem and we are here to solve that problem. So how do you first understand the problem? Two, design the problem so that actually design meaning write it down. How do you record the problem so that you can explain that to somebody else? So the person who's writing down may not be the person solving the problem. Right? Now, there's a technical term for that, requirement gathering. Right? Requirement gathering is where we try to understand the problem. Right? Without knowing the problem, we can't give a solution. So requirement gathering is a very, very important thing. So to understand the problem, here are some questions that we can ask our customer or whoever wants the solution, right? What is being done? Meaning, what is going on now? What are they doing here? As an example, I took accounting package, right? So if you go to the accountant, you ask the accountant, okay, what is being done? What are you doing here? Right? And then how are you doing it here? And then there are a lot of things going on in that room, right? So then we ask, okay, what is the frequency or how many times a day you are doing or how many times an hour you are doing this? Now, let's say we want to automate money collection from the cashier. So we go and look at the cashier. So we ask, what are you doing? So he or she might say, I'm collecting money. So we ask, how are you doing it? He might say, okay, people come with a slip. The slip says, slip has some information about their account number and the purpose of the money being transferred. And then I collect their money from them. And then I give them another slip saying accepted. And end of the day, I had to bundle all the cash and give it to my manager. And there's a book I'm maintaining about how many people came and how much money each person gave to us. And then at the end of the day, I have a total from the book. And I also have cash with me that I can calculate, and then that cash total and the book total must tally. And once it is matching on tallying, I will give both to the manager. So the frequency of task, okay, people come every hour. So it's a ongoing work from 9 o'clock to 5 o'clock, or let's say 3 o'clock, right? And then what is the volume of decisions or transactions? How many people we are talking a day? Are we talking about 10 people or 100 people or 1,000 people, right? And then what are the kind of problems you are facing? We are asking the cashier now, right? What are the problems you are facing? You might say, okay, some people write down 10,000 and then they have a broken 1,000 note. So I can't accept that 1,000. So I have to amend the 10,000 in the paper to 9,000. So that's one problem. Or some people come, they don't bring their national ID card. Now that's another problem. Or some people come, they don't write down their account number properly. So see, these are some of the problems that we get from the person using the system, right? So let's say he's using a manual system. Now, our responsibility is to understand the problem and then give them a solution. Okay, so to do that, to understand the problem, here are some techniques we can use. Interviewing, like I did now, right? You go and talk to the person, talk to the cashier, interview. And then if you can't meet them physically, you give them a questionnaire and say, right, please go through the questions and write down the answers. Or you can look at existing system. Now, for example, he said he's writing down the money he's collecting, and then he has cash with him. So he gives that to a manager. So we can study that document. By studying that, we can find out, okay, how many people have come today, how many transactions were done, what is the kind of total money that we are talking daily basis. So for that, we need to take records of, let's say, last couple of months to understand some things in detail. And then we try to understand the whole business. What is he doing with the money, or why is this business collecting money? So then we realize, okay, this is a bank, and collecting money is one part of the bank. So we need to now go out and have a, we call it bird's eye view, to understand what else is going on. Then we realize, okay, it's a bank. They also lend money. They give the money away to people. So how does that work? You know, various things of that nature comes in. But that's a very holistic view. We may not be able to do everything, right? That's another concept we'll get into. Understanding the scope of the problem, but only solving what we can, which is very important when it comes to your project management. So here are some issues that may encounter if you do not understand the problem first, right? Failures, incomplete problem definition. That means the problem is not properly documented. So we know only half of the problem. And then incorrect program goals. So the goals are not discussed properly by multiple parties. So different people have different opinions about the goals. So that's another problem. And then rework to deliver required outcome to client. Now rework means something is broken, so you have to do it again. Now in electronics, let's say you make a beautiful looking circuit, and then once the PCB is done, the manufacturing is done, you realize maybe the capacitance is too much. So you have to either fix it on the board or go back to the drawing board and do it completely, rework, that is called. So in the software development also, there is rework. It is generally very expensive because rework requires more time from the developers. That leads to increased cost, which means to delayed delivery, because you will not be able to meet your deadline. Everything starts from the biggest problem, not understanding the problem. Okay. And if you look at the last point, due to the depth of information required, requirement gathering is also known as detailed investigation. Right? So detailed investigation means you go with different ways to capture the problem. So in fact, when it comes to a real world software building, you may use days and months sitting with people to understand the problem, right? You spend days and days observing, maybe recording to understand exactly what is going on. And remember, we are not going to automate what they are doing right now. That's a very common mistake we are doing. If the person is doing a wrong process, a wrong way of doing it, if you automate that, you are doing the wrong thing faster. So we also need to understand what is the right way of doing it. And then we automate it, and we will then do the right thing faster. Right? So it's very important then to have a clear problem statement. Now, in that, we need to be clear about the project scope. What is the scope of the project? Like, say, for example, how many features are there? 100 features, 200 features, 300 features? What is it? When we have a number like that, our team is focused. So we know, okay, the whole project has 300 features, but we are doing only 100 features. So the whole team is now focused. Right? And we can also track the project. We can say, fine, we will first finish the first 10 features within 30 days. But the second 10 features will require 60 days, something like that. So we all discuss these things and then try to agree on how to go about doing it. So essentially, everyone agrees on what are you going to achieve at the end of the project. So this communication is very, very important. Now, talking on the identification of the problem, we looked at interweaving and various things. Now, how do you identify the solution now? Since we are in software engineering, we are trying to solve the problem by way of coding, by way of writing software. Okay. Now, many people think coding is the most complex and it is the most expensive thing, and that will take a long time. Not really. The longest time will take for understanding the problem. For business analysis will take long time. Whereas if the person or people or the team who studies the problem can come up with the fantastic documentation on what the problem is and what the solution is, then the programmer can do it very fast, right? So the programming is not the slowest thing. Programming can be the fastest thing, provided the team understand what the problem is. Okay. One more thing. Now, every problem can also have more than one solution. So the accounting system, as we discussed, there may be different ways to solve that thing, right? Now, if people are coming with cash, can we give them automated cash deposit system? So if they are not, okay, then comes, okay, they are not IT savvy. They don't know how to operate a computer. Then, okay, can we give them their native language, Sinhala and Tamil, and make the process very simple? Put the money to some place, type the account number and the phone number. And then screen can display whether the account number belongs to a certain account. If they agree, they press yes. Otherwise, they type it again. Something like that, you see. So there can be more than one solution to the same problem. But at the same time, there can be more than one solution. The teams, that is the solution provider and the client, must agree on what the most suitable solution will be. Okay, so we looked at the problem side, we looked at the solution side. Now, how can I explain? Now, say if I'm the BA business analyst, how can I explain this to the programmer, the programming team? Right, so that's another big issue, because this is communication. How can I communicate this to the programming team? So number one is where I can do a flow chart. A flow chart shows a flow of information. Right, it's a simple diagram which has a starting and ending and decision making process, stuff like that. So we'll see how it works. Then I can also go one step further and do something called data flow diagram, or DFD. Now this is another way to represent the flow of the data going through the system. Or if I'm not a graphical person, I'm a more of a, let's say, a text person, I can try pseudocode. Right? I can now pseudocode, as it says, pseudo mean not real. Okay, unreal code I am writing. What does that mean? Pseudocode is not English. Pseudocode is not Java. Pseudocode is something in between. So pseudocode is another way to communicate the problem or the solution to another person, right? So these are the tools we can use to document and communicate a problem and a solution. Right. Now, in order to solve any big problem, we don't go and solve the whole big problem at once. If you observe any big problem, you will notice you can break it down into, let's say, smaller components, or we call it modules. Right? So you break down the big problem into small problems, actually small modules, and then you start building or finding solution to each small module. Okay. Now, if you take a team, now accounting package, again, I'm taking it as an example. One person may not be able to write the entire accounting package. So you may hire a team of people to build it. So maybe one team will be looking at the cashier's problem, another team will be looking at inventory problem, another team may be looking at the general ledger problem, things like that. Yeah. So, but then at the end, you need one program, one accounting package with all those modules in hand. Right? So we need a way to control these modules and make sure they all work together. This is one way to do. Another way to do is to build the whole thing as one monolithic solution. Monolithic means one huge big problem and a big solution. So if something goes wrong in one part, the whole solution is breaking down now. Right? Maintenance is very difficult, because if one part in some area breaks down, it will break down the rest of the things also. Yeah. So monolithic solution is not a very good way to solve complex problems. It might be okay for small problems, but not suitable for large problems. So in order to break this monolithic solution, we go a step further. We apply the modular technique. So what are the advantages of modular programming? It enables faster development time, because you will be working parallelly. So there will be multiple teams working at the same time, tackling one module or one problem at the same time. So there are, let's say, 5 teams building 5 different modules. And another big advantage is every module can be tested independently. So if one team is working on something, and that team can work on independently and test their module, while the other team is busy building other modules and testing those modules also. Because these modules are smaller than a monolithic application, it's easy to maintain, easy to find bugs, and also easy to maintain on the bigger program as well. Okay, now we looked at some theories. Now let's get down to some actual examples. When it comes to modules, is it top-down or bottom-up approach? Right? Meaning there are two ways of looking at modular systems. Now, here's an example where I'm trying to build a payroll processing application. That's on the top. So we need a payroll application. So payroll application can be broken down into three different areas: employee data, calculate net pay, and then print payslip. So these are the three modules I can think of. The big one is payroll processing, and it is broken down into three simpler modules. And if you take the calculate net pay, inside that I have calculate gross pay, calculate deductions, and also update employee record after calculating. Under print payslip, I have get employee record, get the net pay details, and also get the leave records. So in this approach, this is called the top down. You start from the top and you keep going down. You expand as you go down. Okay. And each case, as you can see, I have one simple module to worry about. When you say get leave record, okay, that is one module. It might have an interface to the, let's say, thumb scanner. Maybe it will download the information from the thumb scanner and then clean that up, remove the duplicates and wrong records, and then sort it according to the timestamp, and then send it to the next module to calculate the time differences. Maybe calculate the absenteeism, and also if you are paying hourly, calculate the number of hours required for the salary, things like that. So all that can be done in one simple module. Here is another way to look at it. This is called the bottom-up approach, right? So in this system, we start at the bottom. So which means we start with all the features. We look at all the features, and then we try to look at grouping them, right? We try to see whether we can group them, and then we start going from bottom to top, one step at a time. So if you look at all the features, this is the calculator, by the way. We have square root, we have algorithmic value, logical not, all sorts of different ways of calculating things. And then we realize the first three require a single input in order to do the operation. Like square root calculation, you only need one value, isn't it? The second two, comparison and logical and, requires two inputs in order to do that. And the last four requires multiple input operation, right? And then we can see these three groups which we created out of those 8 groups, or rather 8 units, can be connected together in order to create a calculator, right? So at the end, we have the calculator. So the calculator, if you come from top to bottom, calculator has 3 modules: single input, 2 input, multiple input. And then single input has certain things, 2 input has certain things, multiple input has certain things. But the way we built it was from bottom up. First, we wrote down all the features we wanted. Then we started grouping them, and then we connect them together. So this is called the bottom up approach. Right. What else do we have under the approaches? Now, that's a sort of a modularized way of doing things. But going further, how do you progress yourself building the software? One of the most famous, I would say also questionable one, is called waterfall method. And we call it a very rigid or fixed kind of method, right? There is also another one, modern one, called the agile method. It's very flexible. So we look at both of them, because sometimes, although waterfall is fixed, we might need that as well. Okay. Agile, like I said, is a modern way of doing things, modern way of building software. It's a kind of a project management framework. What it does is it breaks down the project into dynamic phases. We call it sprints, right? We call them the sprints. So, for example, let's say you want to build let's say, a mobile phone. You want to build a smart mobile phone. Now, okay, that's a very complex task, but how can you do it? So you break it down. So the first sprint can be designing the circuit board, PCBs, right? So that is your first sprint. And you bring in certain time frame for that. Second sprint may be to bring up the bootloader or the software that you require to bring up the board, right? The third sprint might be bringing the applications. So that's one example. If you're looking at the accounting application I took earlier, first sprint might be to look at, let's say, the cashier module, right? And then general ledger module in the first sprint. So you can have maybe 2 teams or 4 teams working on those. And the second sprint might be to bring in, other modules, let's say payable module, banking module, and receiving module, things like that. So when you do that, it's easy for everyone to know what is going on. As we move forward, we will see the details. It is actually a very flexible way of getting things done. What happens is, when you don't have a mechanism like this, people tend to get worn out, right? They get very tired because there is no limit or a plan of ending work. You are working and working and working, continuously busy, because there is no plans of finish line. There is no finish line as such. So Agile gives a mechanism to enjoy our life and also our work by breaking down into sprint and then working on these sprints. Under the Agile, there are a few more concepts that we use. One is called the Scrum, and the two is called, in Japan it is called Kanban. In the Western world it is called the Lean method, and the third one is called the Extreme Programming or XP method. Now, these are, by the way, mechanisms or methods that you can apply your Agile into the organization or building your application. Now, for example, one team here might use, let's say, Kanban method or the Lean method. Another team might prefer the Extreme Programming method. Maybe another team might say, no, we like Scrum. So no problem. Each one has their advantages. Each one has their way of doing things. So some people might prefer one or the other. Which brings us to a very good concept on sports, right? There are two kinds of sports here, as you can see. On the top, we have a relay race. How does a relay race work? In relay race, there is one person running, and then he has to hand over the pole to the next person to run. So until the first person reaches the goal, the second person cannot do anything. Second person is waiting and waiting and waiting and waiting, right? So that is called the relay race method. Not a very good way of doing things. But if you take an example, let's say the person who's building the database, until he finishes database, let's say the coders can't do their work. Sometimes you can do both parallelly. Sometimes you have to fix the database first and then move on to the next one. It depends on the requirement. But it is not a very smart way to build software, the relay race method. The next method is a rugby approach. What does that mean? The whole team is working as one unit, right? The whole team is one unit. And their goal is what? Reaching the goalpost. Yeah. So everyone has one goal, getting to the finish line. And here everyone is working together at the same time. Of course, in a relay race also everyone has one goal, but they are working step by step, right? Whereas in a rugby approach, we have a holistic approach where everyone is working together towards one goal at the same time. So this is a very good way to look at the agile methodology. Right, which brings us to the end of the presentation. Let me show you what is needed for tomorrow. Okay, so the activity. Let me go to the portal. So the presentation is here. I want you to go through these two links, right? Of course, there will be another document. I will upload that in a while, your worksheet for tomorrow. But essentially, what you need to do is to go to this video clip, watch that video clip. So it's a YouTube link. Watch it and install NetBeans along with the Java requirement. Now, in fact, there are two files you may have to download and install: JDK, that is Java Developer Kit, and JRE, Java Runtime Environment. Probably you may have JRE already, JDK maybe not. So go through the instruction, because be careful there, because you have to copy the file to the right places and also change some system settings. So this is the NetBeans website. That is the website. Okay. You need to select the bundle, because NetBeans can be used to develop all kinds of things: PHP, C++, everything. What we're interested right now is only Java. So select the Java version. Looks like the site is not loading. Please install the latest version. NetBeans is 19, version 19 now. JDK also has a version. There are lots of versions. In fact, that also go ahead and download the latest version. I think the video is referring to an older version, which is all right. Oh boy. Okay. Let me show, while we wait for that, let me show you how the NetBeans look like. This is called an IDE, Integrated Development Environment. I wrote a small program just to see how things work. So this is my first program called the Hello World. All it does is say hello or print hello on the screen. I can click here to run it. And down here is my output window. Right, build success, and you can see the hello world here. If there are any issues, you will see it here as well. Right, so your first attempt is to get this going. I shared another document with you on fine-tuning these things. For example, now this area is called the Java doc code block, right? Because with this, you can automatically generate Java documentation. I'm sure you understand the importance of documentation, right? NetBeans and generate it for you automatically. Gosh, it is still loading. And then there are certain pieces of code you can auto-generate also. So all that is available in the other document. So go through both, watch the video and read the documentation and set up your IDE for next class. Any questions, anybody? I still need to upload a few things to the LMS. I'll try to do that tonight. Okay. I guess that's all for me today. So what we looked at today was to understand the scope of this unit. We realized the importance of building software, building complex software. We also looked at some of the theories behind building complex software. We realized one of the biggest issues is to understand the problem, and there are different ways of documenting the solution, because understanding the problem is one, documenting that is as important as understanding the problem, because that way you can give that document to the coders to understand the problem. Okay, so I hope that is clear to everyone. I will see you next week then.